Welcome guys. So today we will be continuing our topics on genetics. So today we will be discussing about the X-linked dominant condition. Okay, dominant. So here we go, dominant condition and their genetics as well. Now I told you a mnemonic before. You should watch the previous video. So the mnemonic is this is a house, and this house Diana. This is an X-link family. Okay, this is an X family. Family name is X, and there lives Diana and Phil and their baby girl. Okay, so this family, Diana, Phil, and their baby girl, is a family who don't like dominant people. I mean, they are only they that are recessive. Recessive means that these all are recessive, like Duchenne for Diana, Duchenne muscular dystrophy, Phil for hemophilia, ANB, and baby for Becker muscular dystrophy, and G for G6PD. And these all are recessive X-linked disease. Why? Because they like recessive. Okay, just remember like that. Now the next thing is they only like this family, Diana, Phil, and girl. They only like one dominant person who is fragile. Okay, like they like decent persons. Okay, sensitive person. So fragile for fragile X syndrome. Okay. So today we will only be talking about this syndrome, fragile X syndrome, because this one I already covered. Now, so there are two possibilities: either mother's X chromosome is affected or father X chromosome is affected. Both will give you different results. Okay. Now this is very important. You need to find out whose X chromosome is being hit by the mutation. Now let's cover this. Now, if the mother is affected and father is normal, suppose we are having a mother, okay, and she is affected, she is not a carrier, okay. In dominant, there is no carrier, okay, and because you only need one chromosome to be defective. Now, if the mother is defective, we will denote the defective by the dot XX, and the father is normal. Okay, now let's see X not defective with along with X. So this is a female who is a defective. Okay, she is defective and she is female. Now X along with Y combine together to form XY, and this is a defective male. Okay, now when X combines with this X, they will form the normal female, and this X along with this Y will come together to form a normal boy. Now you will come across different questions. Okay, if they are talking overall, I mean, if they constitute all those four children as a 100%, then they will say how many percentage are normal and how many are abnormal. Then you will say, okay, regardless of the sex, 50% are defective and 50% are normal. If they only talk about these males, then you will say 50% of the males, because two males are there. So two males are there, one is abnormal and the other one is normal. So 50% normal and 50% normal. Okay, the total constitutes about 100%. Okay, if they only ask about the male, if they only ask about the female, 100%. Okay, then you will count the female. Defective is one defective, and one is normal. So here again 50% defective and 50% normal. And if they ask you overall, you will say 50% normal and 50% abnormal. Here you can count two are normal and two are defective. And if they ask you overall how many boys and how many girls, then you will say 25% male affected, 25% male normal, and 25% female affected. and 25% female normal. So they can get you confused at any point in the scenario. Okay, so you have to be very clear, and you have to check the question again what they are asking for. Okay, now here you can see uh, they are asking about if the mother is affected and the father is normal, then you will have 50% of the children, either male or female, will have faulty genes. I told you already, male and female both will be affected, okay, and 50% of the persons will be affected, okay. Now let's try the second one, okay. Now the second one is if the father is the affected one and the mother is normal. So what will be the outcomes? Now let's come to this one. So suppose if we are having a normal mother, okay. So here you go. Sorry for the inconvenience. Okay. So if we have a female who is normal and a father being affective, okay. So this is an X-linked disorder. So here we go. X along with the second X, they will form the defective female, and X along with the Y, this will form the Y and normal one. X along with the other X, this will form the defective female, and X along with this Y will form XY. So here you can see that both the boys are normal. Both the boys are normal, and both the females are defective. Both the females are affected. So you can see here now the scenario can be they can ask you when the father is affected, when the father is affected, okay. Now they can ask you that how many percentage overall is affected, then you will say 50% overall is affected and 50% are normal. If they don't if they don't if they ask about the overall, okay, regardless of the sex, overall, if they ask about the male and female perspective, then you will say because there are two females and both of them will constitute 100%, you will say 100% are defected. So easy. And then you will say if uh, you come across a male perspective, then you will count the male. There are two males. So how many males are affected? 0% male are affected. Male, and this is female. So males are 0% affected. Okay. Okay. Now what else? They can ask you the probability, and then where the father is being affected, and they will probably ask about these results. So you need to focus on the last line of the question, what they are asking about. Okay. Now let's read it out. Okay. So why the males are not affected? Because as you know, father has X and Y. Okay. This Y goes to boys, and this X goes to the girls. So all the girls will be affected and the boys will be spared because they get X from the mother, not from the father. So this way they are spared of the disease. Now let's read the last time. So if father has affected and mother is normal, the expected outcomes will be 0% of the male children will be affected because they take Y from the father, not X. And 100% of the female children will have the faulty gene BY because they take X chromosome from the father. Okay, I hope you enjoyed it. Let's see you in another video.